In this tutorial, we're connecting a GPS module to our ESP32. GPS modules allow our microcontroller to determine its precise geographic coordinates, speed, and time anywhere on Earth. Let's start with the power connection. The VCC pin from the GPS module connects to row 19B on our breadboard, which corresponds to one of the 5-volt power rails on the FreeNOV extension board. Next, we need the ground connection to complete our circuit. The GND pin from the GPS module connects to the negative rail on row 15, which is ground on the extension board. Now for the TX pin, the transmit pin, where GPS data comes out of the module. This connects to row 13I, which corresponds to GPIO4 on the extension board. Through this connection, the GPS module will continuously stream NMEA sentences containing latitude, longitude, altitude, satellite count, and other positioning information to our ESP32. The module communicates at 9,600 baud rate by default, sending updated position data once per second. Finally, that's the receive pin for serial communication. We're connecting this to row 15I on the breadboard, which maps to GPIO2 on the rover extension. This pin will receive transmitted data from the ESP32. Serial communication uses a transmit and receive pair, so we need to connect the GPS module's RX to the ESP32's TX pin, and vice versa, to establish two-way communication. Our GPS module is now fully wired and ready to communicate with the ESP32. I'm opening a text file with MicroPython code specifically written for the ESP32 and NEO-6M GPS module. Let's run the code. The ESP32 is now initializing serial communication with the GPS module and beginning to parse the incoming NMEA data. Look at that. The shell is displaying live GPS information. We're seeing latitude and longitude coordinates, speed, number of satellites being tracked, and timestamp information. The GPS module is actively receiving signals from satellites overhead and calculating our position. This data updates continuously as the module refines its position fix. Pay attention to the Thonny shell, and you will see latitude and longitude data, speed, and how many satellites the GPS is connected to. This affects quality. And once you're done recording, press Ctrl+C, and a new CSV file titled GPS root will pop up in the MicroPython root folder. Copy it, and we'll use it for our next exercise.